Okay. We were in 11.1, 11.2, and we got into that a decent ways. So, recapping some of the things we did already, I did not take up these notes, so you guys have them. Um, if you weren't here, I have a few extras, but not a lot. So, you have your 11.1, 11.2 notes, or you're supposed to. Maybe. Okay, so 11.1, 11.2. 11.1 starts off with we can solve equations with squares the same way we typically do. Get the x by itself. And as we work outside in, we take the square root to get rid of the square at whatever point we need it. So we can work outside in, take that square root whenever we need it. I might be out of. I will not have this one be the one turned in, but that was all the extras I had. Okay. So divide by 3, take the square root. What do we add anytime we introduce the square root?
Plus or minus.
Plus or minus. Anytime we put in the square root, we put in a plus or minus. So we went through and then we had this example where working outside in, the first thing we did was take the square root because that was the square was the furthest thing out. We took the square root to get plus or minus square root of 10. And then we added 3 because that was the outside in. And this kind of introduced, okay, we've still got one spare. This kind of introduced the idea of if I could get my problems to look like this thing with a square, I can solve more of my quadratic equations. And so we talked about completing the square. So we're going to look at a few more completing the square examples. So I'm going to make up something. All right. So previous, if I wanted to solve this, previous knowledge says if I want to solve this, I would try to factor. What would we do to try to factor this? Factors of 10 that add up to 8. What are factors of 10? 5 and 2. 10 and 1. Those are all of them. Can I make 8 out of any of those pairs? No. So this can't be factored. That's where completing the square came in of if I want to if I want to solve this and I can't factor, the next thing we could try is completing the square to give it that different form. So we're going to complete the square. And I said on Tuesday, if I have a constant, I just set it aside and say I'm going to ignore that constant. All right. So now with x squared plus 8x, what would I do to complete the square? Yeah. 8 divided by, and then you died out 2. And then what do I do with my 8 divided by 2? Square it. 8 divided by 2 is 4 squared is. Okay, so what do I do with that 16? I add the 16, and then I'm going to move the parenthesis because it's not really doing much. I subtract the 16. This process makes something here factorable. What can I factor? It's a whole expression. That x squared plus 8x plus 16 can be factored. How does it factor? Not x plus 8, x minus 8. X plus 4 squared. It's the x plus b over 2. This 8 over 2 part is what gets put there. Squared. And then outside the parentheses, I have like terms. What do my like terms combine down into?
6. -6.
-6 equals 0. This looks like those problems we were solving in 10.1. If I wanted to solve this, I'd work outside in to get x by itself. So what would be the first thing to do to solve it?
Add 6.
Add the 6. So I have x plus 4 squared equals 6. And then what? Square root both sides. When I take the square root, what gets added in? Plus or minus on the number. So there's a little plus or minus right there. Square root of something squared is x plus 4 equals plus or minus the square root of 6. And then what's the last thing to get x by itself? Subtract that 4. And I talked about we like to keep the plus minus in the middle. So saying -4 would be the same as starting with a -4. Saying -4 plus or minus the square root of 6. And so we have two solutions. We have -4 plus square root 6 and -4 minus square root 6. Okay. Let's look at another. I'm gonna make up a problem to put in the C spot instead. 2x squared plus 4x. That should be good. Okay. If I tried to factor this, how would factoring work? It's not add them. Multiply them. I'd multiply to -18. So what are factors of -18? 2 and 9. 6 and 4. 6 and 3. And there's one more. 1 and 18. Can any of those pairs make the number we need? What number do we need?
6 and 3. No, none of them work out.
I apologize. This is something I've been told many times, or I've been told once. That's a 4 in the middle, not a 9. Do any of the pairs make that middle number? No. The 6 and 3 make 9, and I can see with my handwriting, we would think so. But actually, the 6 and 3 wouldn't have worked even if that was a 9. Anyone know why it wouldn't have worked even if it was a 9? Hmm. the signs have to be different because we made a -18. So we would have needed a +6 and -3, or -6 and +3. So the signs would have had to be different. So even if it was a 9, it still didn't work. But this is not a 9, it's a 4. None of my pairs make 4 either. So if I want to solve this, my next strategy is to complete the square. I can ignore the 9. So I'm going to rewrite it ignoring the 9, setting that far away. But our completing the square process kept the x squared by itself. We saw examples like this, but what do I do to make it look like something I can do the process on? We did something if there was a number in front of the x squared. Huh? Factor out the GCF between those two terms. So it's not fully the GCF, it's just the 2, but it is that same idea. So when I factor out a 2 from x squared plus 4x, I get x squared plus, what is 4x divided by 2? 2x. And I have my -9. All right. Now what's in my parentheses is something I can complete the square on. What is b? Take my 2. That is b. 2 divided by 2 is my next step. And then what do I do with that? Square it. So 2 over 2 squared. I'm going to add 1 and subtract 1. Okay, so now this x squared plus 2x plus 1 is factorable. What does it factor into? X plus 1 squared. The last thing to do before we actually solve for this equal to 0 is to fully complete the square. If there wasn't an equal 0 here to fully complete the square, we would do this. And that is multiplying the 2 in. We distribute it in, and so we distribute it to my x plus 1 squared by just writing it in front of x plus 1 squared. And then I also distribute it to the -1. It's 2 times -1. What's that second multiplication? -2. So I get 2x plus 1 squared minus 2 minus 9. What else can be combined then? 2 and 9 to make -11. This process, this is the final complete the square part. Now, the reason this helps is this is something we can solve for. Can add 11. So add 11 to both sides. What would be the next thing we'd do to get x by itself? Divide by 2. Then square root it. When we add in the square root, what else gets added in? Plus or minus. So we get x plus 1 equals plus or minus square root of 11 halves. We would check to see if we could simplify that square root. I can tell you square root of 11 can't simplify and square root of 2 can't simplify. And then last thing, to get x by itself? -1. So -1 plus or minus square root of 11 halves. And there's our answer. Okay. This process gives us our final way to solve for x. And that is the quadratic formula. Anyone remember it from when they learned it in high school? Anyone learn it to a song? Not a squared plus b squared. That, what you're saying is Pythagorean. Anyone know the quadratic? Okay. You're visualizing it. Okay. It goes to Pop Goes the Weasel or All Around the Mulberry Bush. Okay. Oh, Jackson.
Plus or minus the square root of b squared minus 4ac all over 2a. I'll go back. It's negative. Yeah. Are you on Zoom?
Yeah, I was not doing that.
That's okay. We have it now. X equals negative b plus or minus square root b squared minus 4ac all over 2a.
Oh, I know that.
Yeah, probably had it at some point. But this is the quadratic formula. It is the way we can solve for quadratics that are in that a squared. Why did that make a 9 and not an a? A squared, oh, sorry, ax squared plus bx plus c equals 0. So if I had something like I had before, we had 2x squared plus 4x minus 9 equals 0. And I wanted to fill this in. What would be A, B, and C? If I had 2x squared plus 4x minus 9. What would be A? 2. What would be B? And what would be C? -9. And so we could plug these in. And we'd have x equals negative b. Would be -4 plus or minus the square root of b squared minus 4ac all over 2a. That would be what plugging into the quadratic would look like, and then we could simplify this down. What is 4 squared? 16. 4 times 2 times 9. 72. 2 times 2? 4. 16 plus 72. 88. So we have -4 plus or minus the square root of 88. If I wanted to simplify this further, what things could we do? Can I simplify that square root of 88? Or how would I simplify the square root of 88? It is 8 and 11. Let me do this off on the side. Square root of 88 is 8 times 11. What is 8 simplified down? 2 times 4. Can I take the square root of any of those? And take the square root of 4. What's the square root of 4? And then what gets left inside? the 2 and the 11, which makes okay, do it. See what's about to happen. Okay. So this is -4 plus or minus the square 2 square root 22 over 4. Anything else now that I could simplify down? They're not, okay, so could I add the 4 and the 2? No, because they're not like terms. The square root 22 makes them different types of terms.
Did you cancel the 4?
Could cancel the 4s generally, in that each thing could be divided by that 4. So I'd have 4 divided by 4 is -1, or -4 divided by 4, plus or minus, what is 2 divided by 4? 2, 2 over 4, or 1/2. So we'd have root 22 over 2. And ultimately, this would be as simplified, really, if you got down to this, I'd call it good. But this would be as simplified as I'd really expect. But I want to point out that I picked this problem because we had just solved it. 2x squared plus 4x minus 9 was something we had just solved. But we got -1 plus or minus the square root of 11/2. And here we have -1 plus or minus the square root of 22 over 2. These are still the same. Because remember, the square root of 22 was the square root of 2 times the square root of 11. I'm going to write this off on the side to show why they're still the same. Again, if you got down to this, great. But why the square root of 22 over 2 is still equal to the square root of 11/2. Square root of 22 is square root of 2 times 11. 2 is the square root of 2 times 2. Very weird way of expressing this, but it is the square root of 2 times 2. 2's are the same, and so those could cancel, leaving us with the square root of 11 over the square root of 2. And when I have that same square root, I can combine it into 1, say the square root of 11/2. So we did the process in 2 different ways. My whole point here is we get the same answer, they just look different. Those 2 numbers are the same thing, they just look a little different. It's like how 2 and 4/2 are the same. They'll simplify to the same thing. They'll have the same decimal, but they look different. Now, why does this quadratic formula work? This quadratic formula is generally posed as this magical formula that comes out of nowhere. It's not a magical formula that comes out of nowhere. Math is very structured and organized. And so it comes from the process we were just talking about. It comes from completing the square. So I am not going to ever ask you to repeat this process with the variables. You might need to be able to you will need to be able to complete the square with numbers, but I'm never going to ask you to do it with variables. But I'm going to do it with variables to show you how this turns into the quadratic formula when I solve for x. So when we complete the square, we can ignore the c. That's our constant. I always set that aside to say I'm going to ignore it. And that a in front is a factor that I can factor out of these 2 terms. So I'd have a x squared. When I divide bx by a, I'd have b over a this whole thing, b over a, is our whole quote unquote b that we complete the square with. We always take that term, that number, and divide by 2. Or multiply by 1/2. b over a times 1/2 is b over 2a. After we divide by 2, what do we do? Remember? We take b, we divide by 2, and so b over 2a squared is b squared over 4a squared with exponents. That's our number that we add and subtract. So I am going to try, or I'm not going to try, I will succeed. But I'm going to add and subtract that b squared over 4a squared. So plus b squared over 4a squared minus b squared over 4a squared. It's the same process we've been doing with numbers, just with a, b's, and c's instead. This part right here is the part that we always then reach and say that can be factored. And it factors in the same exact way every time. It factors into x plus b over 2a squared. We always took that b over 2. There's an a now because we factored out this a, but it was always that b over 2 term, x plus b over 2 squared. So we have then minus b squared over 4a squared times a plus c equals 0. At this point, we have completed our square, but we want to simplify. And we would take this number out here and multiply it in. The way we multiply it in is a just gets written in front of the thing in parentheses. X plus b over 2a squared minus a times this thing. I want to point out here is that this thing is dividing by a squared. What is a over a squared? Not 1. I have a divided by a squared. All right, what I'm saying?
Which is 2, 1, 1.
Not 1. They cancel out, but they don't completely cancel because there's 2 a's in the denominator and 1 a up top. So they cancel entirely from the top, but how many a's am I left with in the denominator? Just 1. So a over a squared is 1 over a. So I'm going to use that to say that a times b squared over 4a squared is b squared over 4a plus c. This is still equal to 0. The next thing we always did, because we always had numbers at this point. We always had numbers all the way through. But these are like terms. They don't have any x's on them, so they're like terms, so we could add them together. It's a little gross here because one of them's a fraction, but we could combine like terms by creating similar fractions or same denominator. And I will add those together to have the same denominator. They will become 4ac minus b squared all over 4a equals 0. When we then tried to say, let's get x by itself, this whole thing was a number. It was the first thing that we moved to the other side. Since it's being added, how would I move that to the other side? subtract it. So ax plus b over 2a squared equals the negative of this fraction. Looks like b squared minus 4ac all over 4a. Starting to see some of that quadratic formula forming. Okay, what's the next thing we did to get x minus x? There's still something out here. Divide by that a. I'm going to divide by a. Since I already have an a in the denominator, it's going to raise that power. So I have a 4a squared in the denominator. Now square root. When I take the square root, what comes with it? What do we write with a square root? Plus or minus. The square root of b squared minus 4ac all over the square root of 4a squared. What's the square root of 4a squared? 2a. Well, we're showing why this formula works. Why the quadratic formula is what it is. It didn't come out of nowhere. And then what's the last thing to get x by itself? Subtract the b over 2a. So when I subtract the b over 2a, we like to keep the plus minus in the middle. So it will look like x equals subtract the b over 2a plus or minus the square root of b squared minus 4ac all over 2a. A there. I have two fractions with the same denominator, so I can add or subtract across the top, and I have the quadratic formula. The big thing here, again, I will make you guys complete the square, or I will ask you guys to complete the square. I will never make you do it with A, B, and C. We will do it with numbers like we have been. But the big point here is this quadratic formula that we know we have a song for, doesn't come out of nowhere. It comes from completing the square. It comes from that process we just talked about. So the quadratic formula comes from completing the square. Those two things go together, so and I'm just repeating myself at this point. It's not a magical formula. It has a place it came from. And it's a place that we can do. We can complete the square. We know how to do that. But now we have this formula. So again, when it comes to what to do on homeworks or exams, pay attention to what I ask you to do. I might say solve using the quadratic formula, or I might say solve by completing the square. Follow the instructions. If it's completing the square, it's what we were previously doing. If it's quadratic formula, it's plugging in. So, what's the quadratic formula? X equals? Okay, so in this one, what is A? What is B? And what is C? Okay, so X equals negative B plus or minus square root of B squared minus 4 A C all over 2A. Okay. What is 9 squared? What is 4 times 2 times 5? Oh, sorry. You said 40 and my brain wrote 20. I don't know why. Yeah. You were correct. I just wrote the wrong thing, is what I'm saying. Is you said 20, sorry, you said 40, I wrote 20. You were correct. I just can't get my hand to write the right thing, apparently. Okay, 81 plus 40.
Yeah.
121. What is the square root of 121? Hmm? That is too big.
Say 11.
11. It's still pretty close to 100, and the square root of 100 is 10. Um, so square root of 121 is 11. So we have -9 plus or minus 11 over 4. And this can separate. And this is where what that plus minus means is we have two solutions. We have -9 plus 11 over 4 and -9 minus 11 over 4. What is that -9 plus 11 over 4? 2 over 4 or 1/2. Okay. And what is the -9 minus 11 over 4? -5. Okay. Before this, if we were to try and solve this without our previous methods, what would we try to do? If we didn't have completing the square and we didn't have the quadratic formula, what was our method for solving this? Before completing the square. From the beginning of the semester. Factoring. How would I factor 2x squared plus 9x minus 5? Find factors of 10 that add to 9. We've had factors of 10 today. They're 1 and 10 and 2 and 5. Either of those make 9?
Yes. Yes.
This time we are trying to make 9. How do I make 9? -1 and +10. So we have 2x squared minus 1x plus 10x minus 5. And we've talked about factoring by grouping at the beginning of the semester. What is the greatest common factor of 2x squared minus 1x? 1x. And what's left inside the parentheses?
Oh, yeah.
What's the greatest common factor between 10x and -5? What's left inside the parentheses? And we know we are on the right track because what's inside the parentheses match. So we have 2x minus 1 and x plus 5 equals 0. How do I finish out solving for x? Take them apart and set them equal to 0. 2x minus 1 equals 0, or x plus 5 equals 0. X equals 1/2, and x equals... Hey, same thing, two different methods. So again, pay attention to wording, because I will say on the final, you will for sure be asked a factor. And you'd be for sure asked to solve some quadratics. If I don't give a what to use whatever method. But if I say solve with quadratic formula, use the quadratic formula. If I say solve by factoring, solve by factoring. All right. Another example. 3x squared plus 5 equals -6. This one I want us to solve with the quadratic formula. So, what do you think we would want to start off doing to use the quadratic formula?
A, B.
We'd want to find our A, B, and C, but I'm hearing. Yeah, we want everything on one side. That's an overarching theme of solving things. Put everything on one side. So add the 6x over. And then figure out what our A, B, and C are. What's A? A, B, and C are just numbers in front of those things. So A is just the 3. B
50 to 6 times? Oh, what is that?
B is what's ever in front of the X. So I wrote that way intentionally. It's not just read from right to left. It's identify what's with the X squared, what's with the X, and what's by itself. So 6 is B. And C is 5. All right. Quadratic formula. You left out a word. Square root.
B squared minus.
Oh, okay. Plug them in. So we have -6 plus or minus the square root of 6 squared minus 4 times 3 times 5 all over 2 times 3. What is 6 squared? What is 4 times 3 times 5? And 2 times 3 is 6. 36 minus 60. -24. All right. Uh-oh. I heard an uh-oh, I think. What's our problem? We need an imaginary y. There's a negative under the square root with that 24. So we can pull that out and make it an imaginary. So we have plus or minus the square root of 24i all over 6. It's outside, so I try to always cut off my square root by having a little downward to say my square root ends here, I is on the outside. Anything else we can simplify? But divide the 6. We start with something else, though. We will divide by 6 eventually. We want to simplify that square root of 24. That way we're not dividing by 6 multiple times. So how does the square root of 24 simplify down? What are some factors of 24? 6 and 4. Can I take the square root of either of those? 4. So this is plus or minus 2 square root 6i all over 6. So when I do 6 divided by 6, 1 or -1. I didn't say negative to start, so that's me. -1. 2 divided by 6. 3. So we'd have -1 plus or minus. Sorry. Oh, I think that the right thing was said. 2 over 6 is 1/3. Square root 6i. Okay. Some pieces that go with this are types of solutions. A quadratic essentially always has two solutions. Here, we have two solutions, and they're both complex because of that I. We have the -1 plus this thing, and -1 minus that thing. We have two solutions. Up here, we had 1/2 and -5. We had two solutions. What is determining if we get complex or real, just number solutions? How do I get imaginary solutions? When I have a square root of a negative. There's only one spot in here where I have a square root. B squared minus 4ac. That b squared minus 4ac determines the types of solutions I have. And that b squared minus 4ac is called the discriminant. If b squared minus 4ac is bigger than 0, then I'm taking the square root of a positive number. If I take the square root of a positive number, I get a real number. It might be irrational, but it's real. It's a number that I can get a decimal from my calculator for. And so when I can get that real number, I get two real solutions. So when b squared minus 4ac is positive, bigger than 0, we get two real solutions. When b squared minus 4ac equals 0, what's the square root of 0? 0. So I get plus or minus 0. Doesn't change anything. I get one real solution. And in our wording, or in math wording, we would say formally there's multiplicity 2. Ultimately, questions will be how many solutions are there? We have 2 real, 1 real. And when b squared minus 4ac is less than 0, we have 2 imaginary solutions or complex solutions. Because we're taking the square root of a negative. So the discriminant tells us what type of solutions. Let's look at an example. X squared plus 6x plus 9. I want to determine a number of solutions. So using the discriminant, what is the discriminant? This one will equals, but what is that discriminant formula? That's the quadratic. Just the thing that was under the square root. So in this case, A, B, and C, what is A? B and C. Okay, so we'd have 6 squared minus 4 times 9 times 1. 6 squared is 4 times 9 times 1 is 36. 36 minus 36 is 0. How many solutions do we have if b squared minus 4ac is 0? Just 1. Anyone see what that solution would be? Can x squared plus 6x plus 9 factor
Yes.
into what? I even get you started. What multiplies to 9 and adds to 6? It becomes x plus 3 squared equals 0. And so the only thing we're solving is when does x plus 3 equal 0? When x is negative 3. So when we get that one solution, it's these things that we're factoring into squares. It's our perfect square trinomials. I'm going to skip down to C. What is the discriminant formula? Okay. So in this case, what is A? What is B? -2. And C? 4. So we get B squared, -2 squared, minus 4 times 3 times 4. -2 squared is -2 squared is +4, I heard over there. Minus 4 times 3 times 4, 48. 4 minus 48, -44. If the discriminant is less than 0, we get 2 imaginary solutions. Okay. And then last thing that we can do now with this, and we've really been able to do this since the first week or so of class, is write a quadratic with a given solution set. What this is doing is we're undoing our factoring. When I say I have this given solution set, it means at the end of a problem, I get x equals -3/5 and I get x equals 1/4. Those are my two answers. The zero product principle says those came from factors. So if I wanted to get everything on one side, how could I get everything on one side? Yeah. Not multiplication. If I want to say something equals 0, I want to get a 0 on one of those sides. Yeah, move them all to one side with addition or subtraction. I would add the 3/5 to keep the x positive, but we could add the 3/5 over to say x plus 3/5 equals 0. What would that look like? This one. Subtract it to say what equals 0? X minus 1/4 is 0. Those are the two factors. What, again, repeating what we're doing, we're undoing a factoring process. So we have x plus 3/5 times x minus 1/4 was the factored we had. To undo factoring, I can FOIL this out. X times x,
X squared.
x squared. 3/5 times x. 3/5 times x. This multiplication. 3/5 x. X times -1/4. And last one, 3/5 times -1/4. multiply straight across. And then the last thing we would do is combine these. How do I combine fractions? What would I need? Common denominator. I will leave that as practice, but you should get 7/20 x. Yeah, 7/20 x. And we have found a quadratic. When we make a quadratic with the given solution set, that is saying these came from a factored zero product principle, let me multiply my two factors back together. So looking at another example, x equal -7i and 7i means I got to the end of this problem and saw net x equals -7i and x equals 7i. I reached the end of a solution, got 7i and -7i. If I set those equal to 0 instead, what would those look like? If I got them to say something equals 0. Yeah, just add them and subtract them. X plus 7i equals 0, and x minus 7i equals 0. These are my two factors. X plus 7i times x minus 7i. When I FOIL that together, x times x squared. Will I have an x term? Will I have a term in the middle?
Yeah.
Okay, I've now heard both. Why on either of them? Or let's actually do it. Outside. Okay, outer x times -7i is -7ix. 7i times x is a positive 7ix. -7ix plus 7ix cancel each other. These will go away. And then the last multiplication, 7i times -7i. -49i squared. I squared is -1. So I have I squared minus 49 times -1. -49 times -1 plus 49. So this was the problem I started with to say my solutions were -7i and positive 7i. All right, so that is a bunch of the things we can learn from the quadratic formula. And these quadratic functions we're working with get us into 11.3. And I'm gonna hand out 11.3.
If we see this on a test,
Yeah,
do
what?
you want it to be completely wrote out like this? Or are we able to just skip that second step?
Okay, which line do you say is the second?
Like, one more, that one.
If you can skip to here correctly, you can skip to. Okay.
Okay.
What I mean by correctly is that this one's really easy if one got a plus and one got a minus. The first one we did, notice it started with a -3/5 and it became a positive 3/5. So remembering that the sign changes.
Yeah.
But if you can skip to if you can skip to this line correctly, you are fine doing so.
Hey, bro.
Okay, that's why that keeps doing that.
Daniel Bird. I am Daniel.
Okay, so we've been working with these quadratic functions. We haven't been necessarily calling them functions because they've been just equations. But we talked about functions a while back. And it is, we can actually plot, if I plug in various x's, I can get outputs. Quadratic functions are these things that look like the ax squared plus bx plus c. they have a specific shape to them. Since you guys knew the quadratic formula, do you know the shape that they have? They don't make a square. They're gonna have a curve shape to them.
Sir.
They don't make a circle either. Any other ideas on what quadratic functions look like? The shape? Yeah, it's the thing that's look like U's. So it's gonna have that U shape in some way. They can open up or open down. And whether they open up or open down depends on A. It depends on this A piece. And if A is a positive number, if A is bigger than 0, it opens up. If A is less than 0, the graph will go down. There are two big ways these quadratics can be written. The first one, ax squared plus bx plus c, is known as standard form. This one here is known as vertex form. So a times x minus h squared plus k is known as vertex form. It's because we can read off the vertex. I'm gonna redraw my parabolas so that they actually have a vertex that I can read off. Here, the one I just made, kind of poorly, but nonetheless made. That point there that splits it in half is the vertex. What is that point there that I've marked? -2, 2. And so if I were to write this in vertex form, pretending A is 1, just to make things easy on us. If I pretended A is 1, the vertex form would be 1 times x minus the first coordinate, minus the x coordinate. So minus a negative is a plus. So I'd have x plus 2 squared plus 2. That would be the vertex form of that parabola. If it opened down, I'm going to pretend a is -1 in this case. If it opened down, I'd still do the same thing, but I'd have -1 x minus the x coordinate of the vertex. So the x coordinate is 1. So for the vertex I just made there, I'd have x minus 1 squared plus the y coordinate. What's the y coordinate there? 3. A parabola is symmetric about the line x equals h. This is where my drawings are really bad, in that the parabola is supposed to be even on both sides of that dotted line through the vertex. So through this my drawing is very much not even, but it's supposed to be this nice reflection. The main things I'm looking for with these is open up, open down, and where's the vertex? Okay, so graphing the quadratic function f of x equals -x minus 1 squared plus 4. Open up or open down? Okay, I just heard both of them. Okay, why for either? What is negative? The right in front of parentheses is negative. That means A is negative. Specifically, A is -1, but A is negative. If A is negative, it opens down. So opens down. It has that crown shape. And opens up as a cup shape. So opens down, crown. What is the vertex? One and four. So the thing that trips up the most is the sign changes for the X, the sign stays the same for the Y. So change, same. So 1, 4, going to the point 1, 4. I put my dot, and then it opens downward like a frown. And so our parabola, I'm going to try and at least hit some points correctly. But again, my big things I'm looking for is opening up or opening down. And the vertex being correct, because I really cannot draw a nice parabola with my tech tools. But looking for vertex and opening up or down correctly. So looking at the second one, opens up. Y. What is positive? A. A is positive. Specifically, what do you think A is? 1. When I don't see a number, 1. So A is 1, so it opens up because A is positive. What is the vertex? 2, 1. So 2, 1 opens up. How do you think? We're not going to necessarily go through it, but based on this first page, I'll write them side by side. But how do you think we can get from vertex form, or not vertex form, from standard form, that first one, into, I really cannot write things in the right order, A x minus h squared plus k. What process do you think can take us from our standard form to our vertex form?
Everything that is nominated.
Not quite a denominator thing. Those aren't fractions. That line there was from an underlining at some point. What big process did we talk about before quadratic formula? No, that was a long time ago, but yeah, we did talk about factoring at one point. Completing the square. Completing the square is what took us from our regular quadratics into this form. So that vertex can be found with a completing the square. That process I did earlier gives us where the x and y coordinate come from. If I'm in standard form, so this is standard form, we can find the vertex ultimately with the completing the square process, but through the vertex ultimately ends up at negative b over 2a 4ac minus b squared over 4a. One note, I recommend do not memorize the y coordinate. Just keep that. If we can memorize the x coordinate for the quadratic if we can memorize the x coordinate for a parabola, we can always find the y by plugging it in. But I want to write them both because do those two pieces look familiar? Yeah. The x coordinate is the stuff that's outside on my quadratic formula. And my y coordinate was the stuff under a square root. Kind of. I'm wanting to confirm that I wrote that rightly. Yeah. So the vertex comes from the process of completing the square, and it looks like those pieces from our function. So if I want to find the vertex for the parabola whose equation is f of x equals 2x squared plus 8x minus 1. I would find the x coordinate using negative b over 2a. What is b? 8. And a? So negative 8 over 4? Negative 2. I say don't memorize the 4ac minus b squared over 4a because we can plug in this negative 2 to find y. So y is 2 times negative 2 squared plus 8 times negative 2 minus 1. What is 2 times negative 2 squared? 2 times 2 times 2. Too many. 2 times 2 times 2, 8. Now go back a number and say that one. What is 8 times negative 2? Negative 16. Minus 1. 8 minus 16? Minus 1? Our vertex is negative 2, negative 9. Would this parabola open up or open down?
Yeah.
Okay, I've heard both. Which one and why? There's a negative 1.
Cancel. Oh, is it because the 8 is positive?
Okay. It is because something is positive. I couldn't quite tell what that word you said was. Did you say A or 8?
Oh, I don't know.
Oh, you don't know? Okay. It is because of either the A or the 8.
Well, it's because of the A, but the A is not 8.
The A, yeah. That's why I was like, one of those is true. It's because of the A. What number was A?
2.
A equals 2. Is 2 positive or negative? Positive. So it opens up like a cup.
Oh,
So if I wanted to write this in my vertex form, the function would be 2x plus 2 squared minus 9. Because I can just plug that vertex in, the h and the k. Okay, graphing this quadratic formula, or not quadratic formula, graphing this quadratic function, we need the vertex, and we need if it opens up or down. Let's start with up or down. Does this quadratic open up or not? Okay, down y. A, what is A?
Negative 1.
Then the number, the negative 1, so it opens down. A is negative. So it's going to open down. We then need to find the vertex. What equation will find the x of the vertex? Equation gives us x. There's a formula up here that gives us the x of the vertex. Negative b over 2a. What is b in this case? What is a? So we have negative 4 divided by negative 2. So negative 4 divided by negative 2. Positive 2. Y, there is a formula, but we can do it faster by just plugging in here. So I want to plug in 2 to all the x's. So y is negative 2 squared plus 4 times 2 plus 1. 2 squared is 4. Plus 8 plus 1 makes, I think you went a little too high there. That's negative 4, yeah.
That fine.
The negative is outside. So the 4 is negative. So negative 4 plus 8 plus 1 is 5.
So the vertex is 2, 1, 5.
The vertex point is 2, 5. So we plot a point at 2, 5. So over 2, up 5. And then something that opens down. And there is our parabola. You should either put arrows or at least try and get to finish to the end of the graph. I'm gonna put arrows quickly. All right. We'll finish out that last page on Tuesday.
First one?
Give me the first one, yes. The 11.1, 11.2 one. If you don't have that, turn in the other. But give me the 11.1, 11.2. Huh?
Yeah, both.
There will be a set of practice problems I'll give you next week, yes.
That's